All right, so this is target 9D. We are using graphs and tables to show and compare the different output values and rates of change for different functions. All right, a lot of this is going to be a review for you. So hopefully you do remember it, and if not, here's another chance for it to sink in. So we have a couple of objectives. To identify the different types of functions, exponential, quadratic, and linear, from a table or graph, and to write an equation given data from a table. Okay, so two objectives, and one of which you pretty much already should know, and that's this one, how to match a graph to a function. This part is a review. So given these three graphs here, okay, which one's exponential, which one's linear, which one's quadratic? Well, let's start with the first one. It starts off low and then starts to rapidly get higher. So what type of function is it? Is it linear, is it quadratic, or is it exponential? If you said exponential, you would be absolutely right. Okay, so exponential has a curve, okay, and it starts to slowly rise, and then it starts to rise more rapidly. Or it could start over here and do the opposite. Okay, so it could look like that as well. If it has a curve to it like this, though, not as extreme as in a quadratic, which I kind of just gave one away, but you get it. It's exponential. Next, that one's linear. And how do I know that? Well, part of it is this word here, line. This is a line. Okay, it's straight. There's no curve to it at all. Okay, so if you can remember at least two of these, you should be able to remember the third by process of elimination. So this one should be an easy candidate for that. It's got the word right in it, line. Okay, the next one, I know by process of elimination, that means that one has to be quadratic, but a way to remember that is what letter almost always follows Q in words? And that would be U. Okay? So quadratic, QU, see, and the shape of the graph happens to be a U. All right? So that's just another way, kind of a dorky way to remember it. But if it helps, great. Now let's look at some tables and see if you can figure it out. Well, let's start with the first one again. What are we doing here? Well, the easiest thing to do is look at your y or your f of x values, whichever one, however you like to think about it. So f of x and y are the same thing. And look at how they're changing as x increases, because over here we're adding 1 each time, right? Adding 1, so on and so forth. So what's going on here? Well, from 1/9 to 1/3, I'm not really 100% sure how we got that. And then from 1/3 to 1, well, I'm not quite sure, but it's looking like it's not linear because this is really small. This is still kind of small, but now all of a sudden we jump from 1/3 to 1, then we jump from 1 to 2. So we can rule out linear because it's not adding or subtracting the same amount each time, which means it's either quadratic or exponential. This one is only going up, okay? So let's see if we're multiplying by the same number each time. Because if we're multiplying or dividing by the same number each time, that means it's exponential. So if you don't want to start with fractions, that's fine. Okay, start with the 0 because whatever this is a to the 0. So these numbers are whatever the exponent is. Because remember, if this is exponential, then these numbers represent the exponent, which means that a to the 1 equals 3. So a would have to be 3. Okay, so does 3 squared give me 9? Yes. So basically I'm multiplying by 3 each step, which makes that exponential. Multiplication, division, exponential. Okay, the next one. You have your y value. As your x values go up, your y values go down, but then they start to come back up. So they go down, but then they start to come back up. Oh, what does this look like? This looks like a quadratic. Good. And last but not least, if you look here, each time we are adding 2 as we go up. Okay, so that means that that is, of course, linear because we're adding or subtracting the same amount each time. So, now, how to write an equation given data from a table. So we're going to be given data in a table, and we have to write an equation based on that. So the first thing you want to do is determine the type of function the table represents. by looking at the values. Basically what you just did in the last slide. Okay? With linear, the y or the f of x changes at a constant rate, meaning you're adding or subtracting the same number between each value to get the next one. For exponential, the y or f of x changes by either multiplying. Okay, so this one, adding, subtracting. Exponential, multiplying, dividing. Same number between the values. And quadratic, other than the vertex, y or the f of x values can appear twice for two different x values. Or the other way you can look at it is your y or f of x values increase and then decrease, or decrease and then increase, kind of like I showed you. The next step would be to write the parent function of each type. Now, if you're really good at this, you can skip this step if you want, but do not skip it if you're not good at it, okay? So for linear, that's just f of x equals x. For exponential, f of x equals a to the x, where a is greater than 1, or, I didn't put it in there, but a is less than 1 but greater than 0. Remember, a can't be negative and a can't be 1. For quadratic, f of x equals x squared. Those are your parent functions. Okay. For your third step, build your function from that. So for linear, you're going to use slope-intercept form. Y equals mx plus b. Remember, m is a slope other than 1, because if it was 1, you don't have to put anything there. And that's rise over run, and b is the value of y when x is 0, or, if you want to be technical, the y-intercept. Okay, so if I had a graph, and it went like that, this right here is your y-intercept, which is your b. So wherever that is, so like let's say that was at 5, b would be positive 5, because this is a positive 5. If it was down here, it'd be like a negative 5, for example. For exponential, and hold on, let me get rid of that so you can see everything. Use y equals a to the x plus z, where a is greater than 1 for exponential growth and less than 1 but greater than 0 for exponential decay. Okay, c is going to be the value of y when x is 0. So look for, basically it's the y-intercept again. That's all. All right. And for quadratic, use vertex form, which you should be really familiar with by now. Y equals x minus h quantity squared plus k. Remember that hk is the vertex, the point at which your y values are either going to stop increasing or decreasing, and start doing the opposite of that. All right, so let's look at these tables here. We have this one, and let's look at the y or f of x value. What's going on between each one? Well, this one you can look at and pretty easily see that it's going up by 2 each. Even though these are negative, you're adding 2 each time, okay? Which means it's a linear function, because every time the x increases by 1, the y increases by plus 2, not minus 2. So we start with the formula y equals f of x equals mx plus b. Fill that in with the information we have, which is, we know that the slope is going to be 2 over 1, because that's what we're doing. We're adding 2 each time. The other thing we need to know is what's the b? The b is, remember, whatever f of x or y is when x is 0. So in this case, it's negative 4. So our answer is f of x equals 2, which I got from right here, because that's what's going on between each step, minus 4, because we have a negative 4. Let's look at the next one. What's going on here? Well, again, find x equals 0. That's going to be your starting point, and then go 1 over. So a to the 1 equals 4, which means that between each step, I'm multiplying by 4. Now, it might not be as easy for you to see there, but as soon as you go here, 1 times 4 is 4, times 4 is 16. So we're multiplying, which means that it's an exponential function, because every time the x increases by 1, the y increases by multiplying by 4. So we start with our formula, f of x equals a to the x plus c, and we fill that in with the information we have. Now, when x is 0 and f of x or y, whatever you want to call it, is 1, there is no c. So even though, yes, it's not 0, like it would be for, if we didn't have anything over here for a linear one, then in that case, this would have to be 0. But with this is basically, we're going to treat it like that. So when x is 0 and f of x or y is 1, then you don't put that there. You only have this, and a is by whatever you're multiplying or dividing by. So f of x equals 4 to the x power. Okay? And last part, write an equation for the function represented by the table. So we've done exponential, we've done linear. Now this must be quadratic. Let's make sure. Well, our y or f of x values, we're going down because 10, 5, 2, we're counting down, right? 1, 2. Oh, now we're starting to go back up. So it has to be quadratic. The other thing is we see two of the same y. So that's another clue, because the f of x values decrease and then increase. So we start with y equals x minus h squared plus k. Fill that in with what we have. Okay, we know that at this point is where it started to shift. It went down to here and then it started going up. So our vertex is at 0, 1. Okay, so h is 0 and k is 1. All you have to do is plug that in. That's it. So f of x equals x squared plus 0. Now why isn't it x minus 0 squared plus 1? Well, because we don't need to put, I mean, if you really wanted to, you could put this, but it's pointless. So just leave it like this, x squared plus 1. All right, some tips for success. Don't overthink it. You've really learned most of this stuff. You've had it beat into your heads most of the semester. So as soon as you start to realize that, things are going to be much easier on you. Also, memorize the parent functions for the 3 problems or some variation of them. It's going to help a lot because then all you're doing is plugging things in. All right, that about does it. So you guys have a good one. Enjoy your week at school. Oh, also, make sure your answer looks right. Sometimes if you just take a step back and look at your answer again, you could realize some mistakes. Okay? All right, now, goodbye for real this time.